Hi, this is Michael from Quora Seminar, and I will explain to you how to interpret an OLS result. So I've already downloaded the dataset onto eViews, and now we can start interpreting the equation. So the points we're going to cover are coefficient, p-value, r-squared, adjusted r-squared, Durbin-Watson stat, Akaike-Info criterion, and Schwartz criterion. So first, looking at coefficient, this is the value that shows you the relationship between independent variables and dependent variables. So for example, if you look at age, if there's 1 unit increase in age, there is going to be a 19.2 unit increase in profit. Next, going on to p-value. This is the information you have to reject the null hypothesis. So if you get a value of under 0.05, it means that the variable is statistically significant. Here we can see that age, income, online, and tenure all have values of below 0.05, and district has a value of over 0.05. So age, income, online, and tenure are all statistically significant, while district is not. Next, r-squared and adjusted r-squared. This shows the percentage of how the independent variables explain your dependent variable. We commonly use adjusted r-squared more, and if you have multiple models to compare, you can look at this value and pick the one with the bigger value to select the more optimal model. Next, going on to Durbin-Watson stats. This is a statistics test for autocorrelation in the residuals. Autocorrelation is a characteristic of data which shows the degree of similarity between the values of the same variables over successive time intervals. It will always have a value of between 0 and 4. Value of 2 means that there is no autocorrelation. Value under 2 means positive autocorrelation, while values over 2 indicate negative autocorrelation. Here we have value of 1.997, which means that it is almost 2 and there is barely no autocorrelation. Lastly, we are going to look at Akaike-Info criterion and Schwartz criterion. These help you select the best model that has a good fit but does not overfit. So when fitting models, adding more parameters or variables would increase the likelihood, but this may lead to overfitting of the models. So if you're comparing the value with other models, you should pick the one with the lower values, and that would be the more optimal model. The difference between the two, meaning the Akaike-Info criterion and Schwartz criterion, is that the Schwartz criterion has puts more weight on penalizing the complexity of the model. So that is it from me, and I wish you the best of luck with your work on eViews. Bye.